Hello, 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 everybody, and welcome to, let me tilt this up slightly, there we go. Welcome to math. It's good to see you again. We're back for another week of a look at kind of an intro and a primer to algebraic thinking and starting to get ourselves ready to really dive into algebra in middle school. So today we're going to be thinking about an intro to numeric patterns, okay? And our ICANs are down there. And let me read them for you. I can define numeric pattern. I can explain a numeric pattern using expressions. And I can write an expression that shows a numeric pattern. That's what you'll need, the usual business today. Something to write on, something to write with. And let's just jump right in with our word wall over here. Down at the bottom, we got a new one. A numeric pattern is a sequence of numbers that share a relationship, meaning just that, they move in a pattern. They have a predictable order, a predictable sequence that they're going to go in. It's not just sort of a random with no, discernible pattern or no discernible rule that governs them, right? It's not like 6, 48, a million, 270, 3, -5, 1/2, right? Those are just random numbers that I'm shouting out. That is not a numeric pattern because it doesn't follow any sort of sequence, okay? The pattern behind me, I'm actually going to move the word wall out of the way temporarily. So if you really want to write down the definition of a numeric pattern, I'm going to give you about 10 seconds to do so. Great. All right, moving the word wall out of the way so we have more space for mathematics. The pattern behind me is a numeric pattern. It follows a rule, okay? If we read out the first 5 terms of this pattern, which would go on infinitely if we let it, would be 3, 5, 7, 9, 11. Now, many of you might recognize that pattern already. You might recognize something going on here, and feel free to, anything you notice or observe about this pattern, put it in the chat. Okay, people want to know about it. In terms of this pattern, which a lot of you have already picked up, those are all odd numbers, which is good to know. We're going to think about this to start out in terms of where does our pattern begin? And then how does it move? What's the relationship between one number and the number next to it in this pattern? And I've already seen somebody says you start with 3 and then add 2 every time. Would you agree? We're saying we're starting with 3, and then we move 1 step away from the start and we are adding 2. Move another step away, we're adding another 2. Move another step away, we're adding another 2, and so on. So go ahead and try this on for size. Can you tell me the next 5 terms in this numeric pattern? What are the 5 numbers that are going to show up next? If we go 3, 5, 7, 9, 11, what comes after that? What comes after that? After that, after that, after that. The next 5. Give them to me. First one to put it in the chat wins, I don't know, a slight boost to your confidence. I think everybody that puts it in the chat wins a slight boost to your confidence. And thank you for being here. That's a slight boost to your confidence in and of itself. You're doing great. You're fabulous. Speaking directly to you and no one else. You're amazing. All right. We say 13, 15, 17, 19, 21. Does this continue our +2 rule? 14, 15, 17, plus 2 is 19, plus 2 is 21. So, I'm noticing my numbers are starting to taper off in size there. By the time I get to 33, it'll be almost unreadable. But with this pattern, yes, we're adding 2 every time. Okay, that's the part, we kind of did this in 4th grade, okay, of thinking about trying to figure out the rule for a pattern, where it starts, etc. Now the next step as 5th grade mathematicians is thinking about how can we put each of these terms and write them as an expression. Remember, an expression is a mathematical sentence without an equal sign. So we want to be able to use numbers and symbols. And how are we going to write each of these terms as an expression? Okay, let's go over the first one. Okay, so 3, since it's our start, our expression is just going to be 3, right? We haven't done anything to it yet. So it's just a number, right? Just a number, that's an expression. That's a mathematical expression, right? It's a math sentence without an equal sign. Okay, just because we don't have an operation involved in it doesn't mean it's not an expression. Okay, now for this next one, let's think about where we started and then what we did to get to 5. And let's write that. So we have 3, and then 3 plus 2 is going to be our next expression in this term. Now, how would we write this next one? Okay. Conventional wisdom would say, oh, well, yeah, 5 plus 2, right? But what is this 5 really here? Okay, so we're going to go a step further, and instead of saying 5 plus 2, what we're actually going to say is we're going to use our starting term, and we're going to say 3 plus 2 plus 2. That's going to be our third term, is having our starting where we started, and then showing all the steps of how we got to that 7, right? We said we started at 3, and then we did 2 jumps of 2. In the chat, we've saying you could do 3 plus 4. That's another way. It's another expression you could say to match that. And even let's go a step further, shall we? Because what if we said this? 3 plus. What if we wanted to show it with multiplication? And we said, I'm going to write this bigger. 3 plus. And what if we said 2 times 2? Showing here we're starting at 3, and then we have 2 steps of 2, right? Here, we could say, if we wanted to hold this pattern, we're making patterns in patterns here, 3 plus 1 times 2. Would you agree with that? 3, and then 1 group of 2. 3, and then 2 groups of 2. What would come next in this pattern? Three plus, how many groups of 2 would come next? 1, 2, 3 groups of 2. there they are, right? So going a step further than just saying you add 2 every time, of being able to say you start at 3, and then however many terms you are away from the start, you just multiply that by 2. Okay, so for this one, this is actually our 9 here, because our expressions are starting to get quite long. 3 plus 2 plus 2 plus 2, or 3 plus 3 times 2. Okay, and then Ava in the chat says, then after that it would 3 plus 4 groups of 2. Sure, because you're now, let's keep track of we're 1 step away from the start, 2 terms away from the start, 3 terms away from the start, 4 terms, etc. So as long as you knew how many terms you are away from the start, you could calculate what that term would be, right? If I said, let's look at what would the 100th term in this sequence be? You're like, oh, that seems like a lot to count. But let's use our expression here. So if we have an expression of 3, you can see it down there, 3 plus, and let's use our variable of n, right? Because for our first term away from the start, we used a 1. Second term away from the start, we had a 2. Third term away from the start, we had a 3. So this n refers to however many terms we are away from the start. We could even call the start 0 if we wanted to. And does that fit? 3 plus 0 times 2? You bet it does, right? Because what's 0 times 2? 0. Plus 3 is 3. Okay, so this expression, thinking about where are we starting? This is our starting term, or term 0. And then, how many steps are we away from the start? And then what's the interval, the group, at which we're starting? So if I asked you to figure out the 100th term, I see somebody's got it. Somebody said 3 plus 100 times 2. Absolutely. Right? So if you took this all the way 100 terms away from 3, you'd end up with 100 times 2 is 200, plus 3, 203. Amazing. Okay. Let's go over a couple more on our digital whiteboard to get into the habit of writing these patterns. So here's our whiteboard. We've still got our order of operations up there, even though we kind of don't need it. So let me move it just to give us some more space here. So here's our pattern. 10, 11, 12, 13. So start with, first thing, write the next 5 terms in this sequence. This is something you're going to have to do on your exit ticket, so get in the habit of that. First step, write the next 5 terms. So what would come after 13, and then the next 4 numbers after that in the sequence. Once you're done with that, then start to think about how would you write each of these as an expression. What's your starting term? And then what do you need to do each step of the way? So I'm seeing a couple people in the chat. Yep, 14, 15, 16, 17, 18. Right? We're just moving by ones here. So if we had our next 5 terms, 14, 15, 16, 17, and 18. Nice. Now, expressions. Let's do our first, just these 4 terms at the top, the 4 I gave you. Right? So starting with 10, then we have 10, and how do we get to 11? What operation do we need? Yeah, we're adding 1 every time, so 10 plus 1. This would be 10 plus 1 plus 1, or 10 plus 2, right? 10 plus 1 plus 1 plus 1 gets us 13, and so on. So what expression then can we write with a variable, where the variable is showing how many terms away from the start we've moved? What could we say here? And this can be the tricky part. And remembering what your variable, if we go back to our full cam here, looking at this variable of n. This variable of n refers to the number of terms away from start. Okay, so you can take any number and plug it in here, and that's going to mean the number of terms away from the start. If you plugged into 10 here, that would mean taking 10 steps of 2 away from your starting number of 3. Okay, so let's go back to the whiteboard. What kind of expression could we write here then? So we know it's going to be 10 plus something, and then how are we going to say, so for this first one, so 11 is 1 step away from 10, we wrote a 1. 12 is 2 steps away from 10, and we have 2 1s. 13 is 3 steps away from 10. We wrote 3 1s. So could we just say the number of steps away from 10 is how much you subtract to find that number? Sure. So we could just do 10 plus n. Or 10 plus x, or 10 plus y, or 10 plus whatever you want to use as your variable. 10 plus star if you want to. It's fine with me. Okay. The other thing you could do here, like our last problem, is do 10 plus 1 times n. It's a little bit redundant because 1 times anything is itself. But this expression is also accurate. Maybe gives us a little bit more information than we need, but I would rather have more information than we need than not enough information. Okay, so I think that's the key here, is really thinking about every single one of our expressions is going to start with your starting term. And then we're showing the change in our pattern. So if it adds 1 every time, then we'd show that, plus 1, plus 1, plus 1. Right? If it adds 5 every time, we'd say plus 5, plus 5 plus 5 plus 5 plus 5 plus 5, or using multiplication to write that out as well, right? Okay. Let's try one. We're going to try two more. We'll go quick through this one. Take a look at this one. What's happening here? Start with the next 5 terms. Then try writing it out as an expression. I'm going to skip right ahead to step 2, but you write out the next 5 terms, 20, 19, 18, 17. What comes next? Okay, in terms of an expression, if we're starting at 20, okay, and then let's look at the next term, our 19, in relation to 20. 20 plus, or I'm seeing a few people in the chat say minus 20 minus 1. Next would be 20 minus 1 minus 1. Right? Or 20 minus, you could do it this way too, 20 minus 2 times 1. 20 minus 3 times 1. And so on. So then what would it look like if we added in that variable, where the variable represents any number in the sequence, any number in the numerical pattern? It would go 20 minus, let's use A this time. Right? This is the first step away from our start, so we subtract 1. This is the second term away from our start, so we subtract 2. This is the third term away from our start, so we subtract 3. All right. And let's see, 16, 15, 14, 13, 12, 11. Yep, that would be the next patterns. We'd eventually get into 0 and then negative numbers, right? If you went that far. Okay, let's see. Minus A times 1. Yeah, you could do it that way. Or, can you see this far down on the whiteboard? Yes, you can. 20 minus A times 1. That works too. Make sure to put the your subtraction symbol outside the parentheses. Okay, because this is actually, if you did it that way, it would actually be 20 times negative A times 1, which is a much different thing. Since we're not getting into negative numbers, we won't worry about it. So subtraction symbol on the outside of the parentheses. Because again, we're going to do that subtraction after we've multiplied inside the parentheses. Let's try one more, because I want to try one with some more stepwise motion here. Whoop, that's last week's lesson. Let me erase that. Okay. Erase the whiteboard before your lessons, teachers. Okay, let's try this. Let's try 8, 12, 16, 20, etc. Okay, start with the next 5 terms in the series, and then think about building that expression. So in our pattern, what's our rule? What are we doing every time? Every time we move from one number to the next? Are we adding or subtracting? Are we multiplying or dividing? Those are pretty interesting patterns if you were to multiply them. In this case, we're adding, but we're adding how many every time? Okay, we say in the chat we're adding 4 every time. I would agree with that. 8 plus 4, or 8 plus 4 times 1. 8 plus 4 times 2. All right, 8 plus 4 plus 4. And then plus 4 again, so now we've gone 3 groups of 4. 8 plus 4 times 3. So now fill in your variable for this equation. E is on the right track. She's just got to think about how much she's going to be adding every time. So 8 plus, and we said our jump was 4 every time. 4 times, and for any term in the sequence, we can use our variable there. So we can go, let's go 4 times z. Or 4 times f. 4 times q. 4 times triangle. Right? Any number or symbol that's standing in for another number. Okay. Yep. Got it in, starting to get it in the chat. Okay. So for the exit ticket today, it's going to be pretty similar. So it's going to ask you to write the first 5 terms in that series. Okay. The next 5 terms in that series. To write it out as an expression, like we did here, either one of these. Okay. And then to try and come up with an expression for, with a variable that's representing how many terms away from the start. That could apply to any term in that sequence, right? If we went back to the whiteboard and looked at 8 plus 4 times f, right? You could figure out what the 100th term of the sequence would be. All you got to do is substitute 100 for that variable and then simplify the expression. You could figure out what the 1000th term in that pattern would be. Just substitute 1000 for f and then simplify. Okay, pretty useful stuff, these algebraic expressions. Okay, thank you to all of you for tuning in. I appreciate you. Small group office hour will start back up in about 5 minutes or so, as soon as I can get my life together. And come in if you have any questions or want any practice problems. Otherwise, I will see you at 1:15 on Zoom for writing, and you will see each other at 12:30 on Zoom for PE. All right, bye y'all. Happy math.